Hello class, welcome to week 12 of Programming Logic with Python. So this week you guys may have noticed that week 11 didn't have the weekly topic overview video that I had originally said I was going to create for week 11, but I ended up deciding against it and deciding to join it with week 12's video because both weeks really cover the same topic, which is object-oriented programming in Python, and I figured splitting the video into two would just give you guys more work to search for the various videos when really it's just one big topic that we had split into 2 weeks because it has so much um, things that are important to learn when it comes to object-oriented programming. So this video is going to include everything together. So when you guys do prepare for test 3, and if you guys are struggling with the concept of object-oriented programming, just come to this video. It has both week 11 and 12 combined into it. So enough with that. So let's get started. Actually, before I get to that, there will be a week 12 lab walkthrough that will still be pushed out this week. This is just the weekly topic overview for week 11 and 12 into one video. Okay, so let's get started. So I do have 3 tabs open. I have one that pertains to just a general overview of object-oriented programming. I have another one that kind of focuses on objects and classes, and then the last one with inheritance. So if we do go to the textbook right here from Mine tab, I'm just going to open it up. So week 11 covered 7.1, 2, 3, and I believe 4 as well. That's really just going to be the first tab that I'm covering over here. 7.5, as far as classes versus instance methods, that is actually also kind of, I believe it's covered in maybe the second tab I have. It might be the first one as well. It might be a combination of both. And then as for class inheritance, I do cover it in this third tab. The only thing I'm not going to cover in this video are the str method and the delete method. I think they're relatively straightforward, so I would just recommend reading through the textbook for those methods. And multiple inheritance, I don't cover multiple inheritance because the book doesn't really cover it as well. I believe if I just click on this, they just kind of tell you that multiple inheritance exists, but they don't actually really tell you um, much about it. So I'm not going to cover it either. I'm just going to cover basic inheritance between 2 different classes because that's really all you're going to need to do your homework assignments and the only thing I might include on test 3. So enough with that. So these 3 tabs, this 1, 2, 3, are what we're going to cover in this video. It's probably going to be a little bit longer because I do have a lot to cover. We're just going to go step by step. I'm going to read through it. And as I read through it, I might stop just to explain certain parts. I might skip certain parts that I think that are common knowledge or stuff that you should just have picked up from reading the textbook. The textbook isn't long. It might take you an hour or 45 minutes depending on how quick you can read. So I still recommend reading through chapter 7 and then coming to this video. So yeah, let's get started. So object-oriented programming. So Python's a multi-paradigm programming language, supports different programming approaches. So um, in object-oriented programming, an object has 2 characteristics, an attribute and behavior. So let's take an example. A parrot is an object as it has the following properties. It has a name, age, color, and it could sing, it could dance as its behavior. So at its most basic form in object-oriented programming, we have a class. So as it says right here, a class is a blueprint for the object. We haven't created the object yet, so just think of the starting point is the class, because we have to create a kind of roadmap in our code that will be followed by all these objects that we'll create later on. So first things first, we have a class and it's called parrot. So like it says, think of it as a blueprint, a sketch. So a parrot Obviously this class is empty, they just created class, and to create a class you start with the keyword of class, then whatever you want to call it. In this case it's called parrot, and typically you would have stuff inside of your class, but because here they just want to show you what a class looks like, so that the code doesn't error out, they included the keyword of pass inside of it. So pass is just going to say, yeah, we created this class, just pass. Continue with the rest of the code or any other bodies of code after it. So that's all they're doing here. This current class of parrot is empty. So if we want to create an object, so this object is like a specific parrot. So like the class represents parrots in general, so like the species, the specific species of parrot. Parrot being a specific species of like a bird. But if we have a specific parrot, like I just went to the animal store, I bought myself a parrot, I named him Jeff. So Jeff is my parrot. Think of Jeff as a specific object of the class parrot. Jeff is a parrot, but he's a specific parrot. He's my parrot. His name's Jeff. So in this case, an example of an object of the parrot class, so they put just obj, standing for object, but you could put Jeff here. So Jeff can equal parrot. And if I want to assign Jeff to the parrot class, I would have to give the name of the class, in this case it's parrot, and then follow it with two parentheses, an open and closed parenthesis. And I don't have to pass any arguments in here, at least not yet. This is at its most simple form, initializing an object of a class. Um, so yeah, that's that. So here we have a bigger example with like the full piece of code. So we have the class of parrot, as we saw up here, right here. This class actually has code inside of it, so it's not passing anymore. They actually put stuff in inside of this class, and I'm going to break it down. So the first thing they put in was what looks like just a variable and a value. And really that's what it is. But there's a specific word for it. It's an attribute. So if we go all the way back up here, so when we were talking about an object, they said an object has the following properties. It has its name, or it could have like a name, it could have an age, it could have a color, and all of these things are called attributes, or are referred to as an attribute of an object. So if we go back down here, they're saying this is a class attribute. So this is just a comment line. So attributes can either be in a class scope or an instance scope. And when I say instance scope, I refer to these attributes right here. So these attributes pertain to the init method. And the init method I'm going to get to in a second. But these attributes exist really only inside of the init method. This attribute up here, the class attribute of species, this attribute can be applied to any method inside of the class parrot. So think of it as like a global variable that can be used anywhere in your program, but this is a global attribute that can be used anywhere in my class. So I could use it inside of the init method, I could use it inside of, if I had another method, um, it could be used anywhere inside of the class. So this is more of it gives you more freedom when you declare a class attribute. And really this class attribute of species is something that is applied to all parrots, because all parrots are, uh, they all have a species, and their species is bird. And then if I'm talking about like, so let's get to the instance attribute. So you might notice that this init method starts with the keyword of def. And as we learned before, def is used to kind of initialize a function in Python. We would usually start with a function with def, and then we would do the name of the function, pass any parameters we might need, and then end it with a colon. So this method actually is a function. It's the same thing, really. A function and a method. It's just another word that they use in object-oriented programming. So there's two key differences. So the first key difference is you're going to indent this method or function into the class, into your class. So my class is parrot, and notice that it's like all the way to the left. So like that just tells me the block of code, or this is like kind of like the starting block of my code, and everything indented after it belongs to the class parrot. So make sure when you do define a method inside of a class, you're indenting it. And when you indent it, you write it the same way. So in this case, it's def, and then whatever the method is called. In this case, this is a special kind of method. It's called the init method. So the init method is really just whenever I initialize a object. So like up here, when I did obj equals parrot, I was initializing a new object of the parrot class. So when I do that, in this case they didn't put any arguments, but when you typically do it, like right here, when I initialize an object for the parrot class, I'm actually going to put arguments inside of here, and those arguments have to match whatever parameters I set for the init method. So this init method is really just referenced whenever you initialize a new object of the class of parrot. So every class you're ever going to create is always going to have a init method inside of it. It's kind of like it's mandatory per se, because if I want to initialize a new object for that class, I need to have that init method so that I can pass certain parameters that might like I guess um, certain arguments that might pass values to attributes or variables. So like that my attribute is name. One attribute that pertains to the init method is name and age. So if I want to give my parrot a name and an age, I would have to have parameters available. So you might notice, okay, well, this special init method has three parameters. It has self, it has name, and it has age. But you're only passing two arguments. You're passing a string called blue. I'm assuming that that's for name. And then you also are passing a integer argument of 10. So I'm assuming that's also for age. So what's actually taking the place of self? Wouldn't this error out? Well, no. So when you initialize a new uh, object for a class, so if I'm initializing a new object called blue and and assign and initializing it to the class of parrot, what's actually happening is blue, this new object that I'm creating, is actually taking the place of self. So when I am assigning these arguments to my parameters of the init method, blue actually takes the place of self. The string of blue takes the place of name, and then the value of 10 takes the place of age. So just keep that in mind. Self is always needed whenever you uh, declare this init method, and whenever you create a new object for that class, that new object's name, in this case blue or woo, will take the place of self. It's just a way of for Python to recognize that, oh, okay, well, this object will have its name and its age, and then this other object will have a different name, and it'll also have a different object name, a different name right here, and then a different age. So it's a little bit confusing, but hopefully I'm sure you're probably like, oh, I still don't get it, but I would say just look over the code a little bit and try to make sense of what's happening here. The last thing I want to go over is why they're saying self period name. So, like I said, this class acts as a blueprint. And so because this is not indented, this code right here exists outside, or this code right here exists outside of the class body of code. So this is just kind of written in the regular program file. So what I'm doing here is I'm referencing this roadmap and I'm saying, okay, well, blue, give blue the name of BLU and the value of 10. But when I initialize a new object, I'm saying, okay, well, this name, give it something else. Give it woo and give it 15. So uh, I, it's kind of the same thing of what I just set up here, but you also have to include it down here. So just make sure you include self as one of your first parameter. It always has to be the first parameter, and then include self for the instance attributes. So right here, if I'm going to include an attribute for name, just include self period name. Or if I'm going to do another attribute for age, just include self period age. So that's it for that. So let's go to methods. So we went over creating a class and creating objects in Python. So at the very basic thing, just take the biggest takeaway from there is this is how you initialize a object, and I'm initializing this object for the class of parent. If anything, for those last 5 minutes I was talking about, at least take that away from it. So let's go to method. So method is these little blocks of code, these functions that we create inside of our class. Like I said, they're called methods. If I want to create, whenever you create a class, you're always going to have this first init method, because this is necessary whenever you create a new object outside of that class. So that's a given. So what if I want to create another method? What if I want to create a method to describe what my parrot does? Because that's really what methods are used for. These attributes describe the parrot itself, but if I want to describe the actions that my parrot does, I would create multiple methods. So my parrot can sing and it can dance, so I'm going to create a method for sing called def sing. Remember, I do have to include that self parameter. For any new method you create, always include that self parameter. It's necessary. But the second method of sing can also have other parameters as well. It doesn't only have to have that self parameter. It can have a parameter of song. And then my dance method has just the self parameter, which is fine. So if I initialize my object, like a new object, pretend we didn't initialize these other objects. This is just my first time initializing the BLU object, and I'm initializing it with the parrot class. So remember, these arguments that I'm passing are really just being passed through my init method. So that's that. That's kind of just an overview of what I explained up here in example 1, but something else happens here. So yes, I initialized this new object of BLU, but now I'm calling our instance methods. So this is the instance, this is used to initialize a new object, but these other methods that we create, these are kind of like they refer to them as instance methods. So like I said, they're used to describe activity or actions of the specific class. So the way to do it is you would do the name of our object, so BLU, period, whatever the name of the method is. So if my method is sing, I would do BLU period sing, and then I would have to pass the proper arguments needed for that method. So in this case, remember, we're not passing an argument for self, because self is really just BLU is taking the place of self. So I really just have to pass an argument for song. And what does song take? Song is probably going to take a string, so I can pass a string right here. And then for the second dance method, when I do BLU period dance, I don't have to pass an argument, because remember, BLU is taking the place of self, and there's no other parameters that I have to satisfy. So I can just leave that empty. So the output will be BLU sings happy, because remember, I'm passing the argument of happy, and then BLU is now dancing. Because when I when I print out BLU period dance, it's just going to return this string. It's going to say, okay, well, return, and then it's going to do first BLU. So BLU is going to take the place of this curly bracket, and then it's going to say is now dancing. And the reason it does that is because of this format self name. So that's that. So let's move on to inheritance. So inheritance is a way of creating a new class for using details of is a way of creating a new class for using details. So okay, that's confusing. So inheritance is it's best to look at an example. We have two classes here. We have the class of bird and we have the class of penguin. And they kind of tell you that bird was the first class that was created, so they refer to that as the parent class. So if I create classes after the fact, these are referred to as child classes. But right now we're just going to focus on one child class. We're not going to focus on multiple child classes. So if you notice something, my first class of bird doesn't have a set of parentheses, and there's no argument inside of it. Because it's just one class. At the time, I only had one class, and I had a bunch of methods inside of it. I obviously have my init method, and then I have these other instance methods to describe what my bird does. Like who he is, and then what he does, he swims. Okay. My child class also has an init method, because remember, every class has to have an init method, and every init method has to have a self parameter, right? Okay, so what happens when, how do I tell Python that this class is a child class and this class is a parent class? Well, the first way you do that is by, when you call that child class, after the child class's name of penguin in this case, you want to include parentheses after it, or not, yeah, parentheses after it, and then put the, inside of it, just put the name of the parent class. So in this case, I knew my parent class was, the name it was bird, so I'm just going to put bird in here, no quotation marks, just write bird as is. And then when we move into our init class or init method, um, you might see that they introduce something called the super function. So when you create a child class, the child class and the parent class both have init methods. So you might be thinking, okay, well, what if when I declare, well, when I create a new object, so like when I create an object for the penguin class, even though it's a child class of the bird class, um, what init method is used when I initialize that new object? Well, as you might think, the the init method that gets preference is the init method that of that specific class. So if I'm creating an object for the penguin class, the init method of the penguin class is the only thing that's referenced. The init method of the bird class is never referenced, so it's almost invisible to the child class, even though that child class is technically the quote-unquote child of the parent class. You would think it would take from the parent class, but it doesn't. But if you include the super function, it will know of the init method from the bird class. So every attribute that exists in the init method of the bird class will also carry over to the child class. And it only does this when you include the super function. So to write the super function, it's very simple. You do super, open, close parentheses, period, and then init. So this is really just saying, think of super as whatever, it's really just representing bird. So really what they're doing here is they're writing bird, period, init, underscore, underscore, init, underscore, underscore, open, close parentheses. So they're really just saying, reference the init from the bird class and everything that exists inside of the init from the bird class. And then add on to that whatever exists in this current init of the penguin class. So by doing that, we don't have to redeclare everything from the bird class for our code to work. We can just say, okay, well, everything that was in the bird class init, move it here. And then whatever I include inside of this init, so like if I have any other attributes I might want to add to it, add those as well, but those will only be able to be referenced if I create an object in the penguin class. So let's see what they do. So they create a new object called Peggy. So this is my object, and I'm creating it with the penguin class. So I'm doing Peggy, and I am referencing a specific method in one of my classes. I'm not exactly sure which one. So Peggy period who is this? So who is this? If I look, there's two who is this. There's actually the who is this that exists in the penguin class, and then there's a who is this that exists in the bird class. So which one do you think is gonna have preference? Well, if I cheat and I look down here, I can see penguin is actually the one that is getting preference here. So let's see. So Peggy equals penguin. Peggy, who is this? So let's see. Well, actually, let's go step by step. So when I do Peggy equals penguin, what is that actually? Well, that's initializing the um, the object for the class of penguin. Peggy period, who is this, should be, let's see, so bird is ready, penguin is ready, penguin, swim faster, run faster. Okay, so, okay, that makes sense. So they're just saying that this doesn't actually print this out. That's what was confusing me. But they're just showing you what now belongs to that penguin object. So when you initialize a new object called Peggy and equate it to the class of penguin, what you're really doing is you're allowing Peggy to have access to this init, which contains a print statement of bird is ready. So that's why they're saying output is bird is ready, but you're also giving it access to this other print statement because this print statement only belongs to the init of the class of penguin. So the class of penguin, because of this super function, has access to both inits. So thus it has access to both print statements, which is why they put both print statements down here. Bird is ready, penguin is ready. This third line of output is actually, it actually would get outputted if you include this call right here. So if you do Peggy period who is this, actually exists, like I said, in both classes, but the who is this from the penguin class will take uh, precedence over the bird class because it exists directly inside of the penguin class. So that's why penguin gets printed out and not bird. So for the other one, so when I do Peggy period swim, so the swim method doesn't exist inside of the penguin class. So when it doesn't exist inside of a child class, it's going to look in previous classes. So because remember this child class is a child of the bird class, and the way it knows it is because I included bird right here, it's going to check the bird class now. So it's going to check the bird class in all of its methods and say, okay, well, is there a swim method inside of the bird class? Yes, there is. So it's going to print out the string of swim faster because that's what's inside of the swim method. That's what the swim method does. And then the same thing with run. So run doesn't exist in the bird. So well, since the run method exists inside of the child class, it never has to go to the parent class to find it. It can just say, okay, well, run exists inside of my class. I'm just going to print out run faster. So that's really all they're doing. That's really inheritance. The two key takeaways is if you want a child class to inherit from a parent class, include a set of parentheses and then write the parent class inside of it. And then if you want, well, it's not if you want. The whole point of a child class, of creating a child class, is so that you can add on certain attributes to the parent class that you might only want to, I guess, belong to that child class. So yes, there's a lot of different kinds of birds, but penguins have certain attributes that other birds may not. So that's why I'm going to create a separate class for penguins. I might create another class for a different kind of bird, like a bald eagle, that might have certain attributes or characteristics that a penguin might not have. But all birds might have attributes that exist across all of them. So that's why we would have those attributes, those universal attributes up here inside of my init for my bird class, and then yeah, like specific attributes that belong to specific birds might exist inside of that those child classes for those different kinds of birds. But you never want to get rid of those general attributes that are universal, so that's why we use the super function. So that's really it for inheritance. So let's go to encapsulation, encapsulate, encapsulation. So using object-oriented programming Python, we can restrict access to certain methods or variables. Now in your book they refer to protected and then they refer to private when they do encapsulation. But right here they're just gonna, I guess, talk about private because protected doesn't really do anything. It just kind of tells the user, hey, don't change this object or don't change this attribute inside of my class. It's like a warning thing, but private actually doesn't allow the user to manipulate an attribute if they're trying to do it outside of the class code. So they created a class right here, and this class has three different methods. The first method is our basic init method. Our second method is something like a, I guess, characteristic or an action that a computer might do, or like that might belong to a computer. So in this case, our method is called sell. And then we have another method that says set max price for a computer. Okay, so this class is one block of code. Now, these two statements exist outside of that class piece of code. That's why it's outdented. So the way you can set an attribute as private is to include a double underscore before or after the, or yeah, before the attribute name. So right here we have the self period, because this is just common, something we're always going to commonly do. Self period, and then before the attribute name of max price, I'm going to include a double underscore. This tells Python that, hey, I'm creating a new attribute, but make it private so that people can't adjust the value of whatever I'm going to assign it to. So my attribute is max price. It's a private attribute, and I'm assigning it the value of 900. So that's a set value, and because it's private, if someone's trying to change it outside of this class piece of code, they won't be able to do it. So down here, I see that someone is initializing an object called C. They're initializing this new object with the class of computer, and I know that because it's equal and then the name of the class computer with the open and close parenthesis. Great. Okay, so now they're doing C period sell. So C period sell is going to print out this piece of code. It's just a print statement that's going to say, okay, selling price is, and then it's going to do like uh, whatever the selling price is. So in this case, it's probably going to be, so format self period max price. Okay, so they want, this format is really just inserting the self max price, so this right here, into these curly brackets. That's all it's doing. So selling price is going to be 900. And the reason we do that is because we don't know the value of self price. Well, at least they didn't when they created this method. If they did, they would have just written 900. But because they didn't know, that's why they wrote this piece of code. But this is really just inputting whatever this value is right here. Okay, so that's what they're doing here. So that's going to be our first line that we see in our output. That's fine. It's really just displaying this. Okay, let's move on. So change price. So now we're going to try to change the price outside of our class of computer. So we have C period underscore underscore, because we have to reference this attribute from the computer class as it is. Obviously, we don't have to include the self period because self period is really just C period. It's kind of like the same thing. So underscore underscore max price, and I'm trying to change the value of max price to 1000. So I equated it to 1000, and now I'm going to try to display that output. So that's what I'm going to do, C period sell. And what that should do is it should take max price, and instead of giving it 900, it should now change it to 1000 under normal circumstances, right? Well, when we look at the output right here, it's still giving me a selling price of 900. Why is it doing that? Because remember, this is not your typical attribute. It's a private attribute because it has the underscores, which means just because it accepted my code right here of equating to 1000 without returning an error, it doesn't mean Python actually executes it. It'll take in the code and it'll say, okay, well, he's trying to do this. And then what Python really does is they say, okay, well, it's a private attribute, so I'm not going to apply whatever you just gave me. I'm just going to kind of throw it away. I'm not going to give you an error, but I'm not going to really do anything with what you just gave me. But if I did want to change it outside of my class code, they do give you the option of using the setter function. So to do that, you would just do C period set. And now you don't have to include the underscores when we use the setter function. You would just do set, and then you would do max price, um, and then you would equate whatever the new value you want to set to it. They don't include this in your textbook, so we're probably not going to use this, but I did want to kind of show you it. And as you see here, it did change the value of selling price to 1,000, but don't worry about that too much. The setter function isn't super important. So let's see what else. Yeah, that's really it. Polymorphism we're not covering, so don't worry about that. And that's it for this tab. Let's see where we're at. Okay, we're currently at about 36 minutes. Okay, like I said, it's going to be a longer video. Okay, so Python objects and classes. This is just kind of like an overview of what we just went through in the previous thing. So defining a class as, yeah, this is an overview, so it's class, whatever you want to name of the class. Here they say typically try to give a string or like a comment that they call it a doc string that kind of tells like your other coworkers what this class is for. Like what does it do? So they say give a brief description of the class. So you guys don't have to do it. If you guys want to, by all means, but I'm not going to mandate you guys to do that. So let's move down. So we already know how to create a class, and then whatever the class is. Here's a doc string. We already know that this attribute, because it's defined inside of the class and not inside of a specific method, we know this is a class attribute. Here we have a method called greet. Typically you would have another method for init, but here they just got lazy and they didn't write it, which is fine. So we know that. So create an object in Python. We already know if we want to. We have the person class up here. If I want to create an object for the person class, I just do whatever the name of that object that I want to create is. In this case, they want to call this new object a specific person, so Harry, he's like a specific object of a person. Yeah, he's a new object of the person class. But think of him as like a actual person. And the person class, think of that as just like the human race. There's a lot of different humans, but one specific human is Harry. And that's how you would declare a object for the person class. We kind of already went over this in the previous tab that we went through. So let's move down. This is all the same. I don't really have to go over this. So constructors in Python, so they're once again going over the init method. So the init method is a special method. They call it the constructor method. So if I do ever reference the constructor method, I do think I did call, or actually, Cengage referred to it as the constructor method. So when they say that, they just mean call the init method. And remember, the init method is included in every class we ever create. It's pretty much mandatory, and it's super necessary whenever we create a new object, because all parameters that are inside of our init method, all attributes, so like the parameter of r, I, and then the attributes of real and image, they're necessary when we call the when we declare a new object, and then we declare it for a specific class. So here we created a new object called num1 for the class of complex number, so complex number, and I'm passing two arguments, so 2 and 3, and those arguments get put into here. They don't get put into any other method, they get put into the init method. So 2 and 3 get put into here, and as we see, the self period real. Self is just something we always write. The attribute of real is equated to the parameter of r. So r is 0 by default because, so here it's kind of funny. They gave you two parameters, but they gave them default values. So say I created another object. So right here they created another object called num2, and they're initializing this object to the complex number class. So same thing we did with for num1, but they're only passing one argument, so 5. So this argument's going to take the place of r, but we don't have an argument for I. So if we didn't have an argument for I, and we didn't have a default argument for the specific parameter, it would usually give us an error, right? But because there's a default argument of 0, like a value for, or default value for this parameter of 0, it's going to accept it. And then they do this attr. Don't worry about that. I just kind of want to show you what that was. So the delete attribute in objects, this concept is relatively simple. So if I have a object of num1, and this object belongs to the complex number class, and this num1 is passing values of 2 and 3 to the complex number init method. Say that's fine, okay, great. But now I want to delete a value from this complex number init method, because remember the complex number init method, right here, the complex number init method of this has two attributes. It has the real attribute and has the image attribute. And these are both being equated to the parameter of r and I. So when I declare a new object, like I did here, and I'm passing these two values or arguments to this init method, r is being replaced with 2, and 3 is being replaced with I. And remember, r is being assigned to real, and I is being assigned to image. So if I do delete num1 period image, what do you think happens? Well, what happens is 3 no longer, the value of 3 is no longer being assigned to the attribute of image. So when I do num1 period get data, which is a whole nother method inside of the class or the complex number class, this method of get data is supposed to take the value of real, which in this case was 2, and it's supposed to get the value of image, which in this case was supposed to be 3. But because image no longer has the value of 3, what do you think happens? We're going to get this traceback error, and it's going to say complex number object has no attribute image. Because image no longer has a value, we can't really return the value of image, so that's why they give us this. So that's really what delete does. I can also delete the whole method of get data if I wanted to. So to do that, I would do delete complex number period get data, because complex number is the class, and then get data is a specific method for that class. And then you could delete the object itself. So originally we created the object of C1, or this is a new object we create. So C1 equals complex number, and we pass the two arguments of 1 and 3. And say like this object was like an employee. Pretend it was an employee. Employee 1. And this employee worked at our company, so I created an object for this employee. But then he decided to leave the company, so there's no point in having him in as one of our objects for the class of employees. So I'm going to get rid of this employee. I'm going to delete C1 or employee 1 so that because he no longer works for our company. So to do that, you would just do DLE and then C1, the name of whatever object. That's all they're showing you here. So that's that. So that finishes that tab. Last thing I want to cover, let's see where we're at. We are at 44 minutes. Okay, so that was pretty quick. So this last thing is inheritance. So inheritance is a powerful feature in object-oriented programming. We kind of covered this in the first tab actually, but I'll briefly go over it again. So let's see, what's the best way to... Okay, well, they kind of broke it down to separate snippets of code. So we have our parent class of Polygon. So Polygon has our init method. The init method, remember, is used and is required in every class we ever create. And then it has two other methods, input sides and display sides. Great. We don't really have to worry about the stuff inside of it. That's not important for this to understand what I'm trying to get across here. So ignore all of this code. This is just a for loop. This is just a calculation. And then these two are actual attributes. So the attribute is n for number of sides, and then sides for this calculation. So don't worry about that. We have, just think of this as one class, and the class is Polygon. Okay? So let's move on to this other snippet. Then we have another class. So this is our child class, because this was the parent class. So this is my child class, and the way I know it's my child class is because it doesn't have a colon right after the name of the class. If it did, then I would think, okay, maybe this is a parent class, but because it has an open parenthesis, and it has a name inside of it. In this case, the name that I put inside of it is the name of the class, or the Polygon class. That's kind of how I know that this triangle class is a child of this class, Polygon. So that's kind of how you could immediately identify a child class from a parent class. So inside of this child class, of course, I have the init method, and I guess the first thing to notice here is this right here, polygon period underscore underscore init underscore underscore whatever. You might say, okay, well, this kind of looks similar to what you showed me right here of, let me see if I could find it. Yes, right here, of the super function. It kind of looks similar to it, but it's a little bit different. Well, that's because this right here is really what the super function's doing. They just show you it here, but they don't actually want you to write it like this. They do want you to use the super function. So let me see if I can find. Okay, so they don't actually specifically reference the super function, but don't ever write don't ever write it like this. Do use the super function as I showed you earlier. And then they're just saying that there's another method called find area. So what this is really going to do is this line of code is just saying, okay, well, everything that was inside the polygon init method, transfer it over to this child class and place it inside of this child's init method. And obviously, if we had more stuff inside of it, this would be the parent class's init method would be carried over, and then anything else we had would be added onto it. But because we have nothing else, it's just really carrying over everything from the parent class's init method. So it's going to carry over n, and it's going to carry over sides. And then we have this find area method. So let's see what else they're saying. So they say the class triangle has a new method of find area. We see that right here. To find and print out the area of the triangle, here's a sample run. Okay, so we don't have to worry about this. Yeah, they're basically just saying, if I want to use this method of find area, I do need to reference sides, and sides currently doesn't exist inside of my init method, but it does exist inside of the polygon class. So that's really the whole point of having these two classes. You might say, okay, well, why not just put find area up here? Well, find area is specific to the triangle class, but the triangle is similar to a polygon in that it has multiple sides. I believe that's what they say here. A triangle is a polygon with three sides. So we can create a class called triangle, which inherits from polygon. So this makes all the attributes being anything inside of the init function, or the init method, available to the triangle class. And the way we do it is this line of code, but obviously don't write it like this. Write it like using the super function as like this. So you would just do super period init, and this does what this line of code does, without complicating anything. So just use the super method, or super function. Okay, so let's go to method overriding in Python. So I did briefly go over this earlier as well. So when you have a parent class and a child class, so I'm actually going to move back to here. Okay, so we have the parent class, we have the child class. The parent class is bird, child class is penguin. They both have the init method. So what they're saying here is that in the above example, notice that the init method was defined in both classes, triangle as well as polygon. When this happens, the method in the derived class overrides the base class. So they're really just saying the init method from the triangle class, which is my child class, is going to override the init method of the polygon class. Say I didn't include the super function, and I just had a bunch of other attributes in my triangle class. So let's go back here. So pretend this line doesn't exist, and I just have print penguin is ready. So when I do Peggy equals penguin, when I'm creating a new object called Peggy for the penguin class, what do you think is going to print out? Or what attribute is going to be associated to this new object? Just this print statement of penguin is ready. So when I would look at this output, bird is ready will not be included here. It would just be penguin is ready, which is why we use the super function, so that it can take not just the init method from the penguin class, which is my child class, but also from the parent class. But that's not exactly the point that they're trying to get across here. That's important to understand, but they take it one step forward, or one step further. So what they're saying is when this happens, the method in the derived class overrides that in the parent class. This is to say init in triangle gets preference over init in polygon. So generally, when overriding a base method, we tend to extend the definition rather than simply replace it. So that's why we use the super function to extend what currently exists in the parent init method to the child's init method, and then add to it. So a better option would be used to, yeah, the built-in super function. Okay, so they do mention it here. Okay, that's good. So super, open parenthesis, close parenthesis, period init, and then, yeah, they're passing one argument here. Is equivalent to, yeah, okay, so good. I was gonna say, it's really weird, this official documentation doesn't include the super function, but they do. So they're saying this line, which is the correct way of writing it, of the super function, is equivalent to writing polygon init, what we saw up here. It's the same thing. It does the same thing, but this is the preferred way of writing it. So two built-in functions. Okay, so we don't have to worry about this. Okay, so that's, I thought they were gonna go into more things, but I guess that's really it. And I believe that's really as far as the book takes it as well, as far as method overriding. So just let me double check the textbook chapter breakdown just to make sure I covered most things. So we did cover object-oriented programming in Python. We defined a class. We initialized a new object in Python. We added attributes to an object. So like adding attributes to an object is really just, let me see if I could find a good example. So let's say, so this is defining the class, well, yeah, defining the class, defining a object. If I were to add attributes to an object, right here, no, not maybe here. Deleting attributes. No. Well, actually, this defining adding attributes to an object, I think actually this would be what they're referring to when they say that. So when you would typically initialize a new object in Python, it would just be this. But when I want to add when I want to use the attributes from that class for this new object, you would write it like this. So that's really what they are like. Okay, like this. So I have my new object. I'm using the class of parrot. So this object belongs to the class of parrot, and I'm using the attributes from this init, so name and age, and I'm actually giving those attributes values. So that's what they're referring to when they say adding attributes to an object. So you guys know what the init method is. It's always needed for us to, whenever we create a new object for a class, it goes through the init method. It's needed in any class that we create, so an init method is like this. Okay, methods in class, so defining a method. So a method is like a function that exists inside of a class. So this is a method, this is the init method, this is another method. Methods, aside from the init method, methods are supposed to kind of give like actionable things that the class might do. So like in this case, my class is complex number, so what would complex number do? Well, this might not be the best example. Okay, let's go to person. So pretend there's an init method right here above here, they just didn't write it. What would a person do? Like, what's an actionable thing that person does? And that's what methods are used for. A person can greet someone. So that's why they have a method called greet. And the specific thing that this method does is it prints out hello. So passing arguments to instance methods. So if this method had of greet, where's greet? So this method doesn't have any parameters. It does have the self parameter, but it's not an actual parameter. You do have to include it, but it doesn't act. You never have to pass an argument for this self parameter. But say, let me see if I can find another example. Okay, maybe not here. Here, okay. So if we have our class of parrot and this method of sing, my parrot can sing, so that's an actionable thing that the parrot can do. Yes, it has the self parameter, but it also has an actual parameter for me to pass an argument through. This parameter is song. It takes a string. So that's kind of what they mean by passing arguments to instance methods. So an instance method is like this. This is an instance method. They even define it right here. Okay, so that's that. Setting instance method attributes within instance methods. What are they referring to here? Okay, so yes, this is setting instance attributes within. Okay, so it's like referring to the attributes that exist in init inside of your specific method. So you can do that. You just have to declare it the same way you see it inside of init, which is perfectly okay. So actually, what else? I actually need to go back here. Okay, so class versus instance attributes. So as you guys know, a class attribute is, let me see if I could get an example. A class attribute is this. It's something that exists inside of the class. It's universal. It could be used anywhere in the class. A instance attribute is really only referred to inside of that instance. But you might say, didn't you just say you could use the, where was my example? Didn't you say you can use an instance attribute inside of your other methods? Yes. But it's really just like, so, okay. I guess the best way of doing it is right here. So when I'm calling an instance method, so if I'm calling the method of sing or dance for this new object, I would do the object name, the method that I'm trying to call, in this case it's sing, and I'm passing one argument for the parameter of song. And song is actually taking a string, and then self-name, which is up here, is really just taken in blue. So I guess that's the way you would use so self-name up here. So even though self-name exists inside of init, um, because the object referred to init when it was originally created, um, that's kind of how they're saying it's referring to. So right here, self-name exists. That's kind of how what they mean when they say you're using a init attribute inside of a method. Um, it's not directly being used, it's being used because the object originally used it. But if I wanted to refer to something like another attribute that doesn't exist inside of init in one of my methods, I would have to either include that attribute up here, as I did with song right here, or I can just create a class attribute and then just use it inside of this method. So that's kind of the difference. It's a little bit confusing, but I think I explained it better before, earlier in the video. So let's go back to uh, the table of contents. Okay, so let's go down here. So class versus instance methods. Um, I already went over that. Class inheritance, so yeah, encapsulation, class methods, I went over that. That's like the private, um, making certain attributes private. That's really all that is. Class inheritance, we went over that a lot. Overriding init, so that's just saying that every class has its own init, but if um, the child init would override the parent init if you don't include, but if you include the super function, it doesn't override it, it just really builds off the parent init, and then you could add other attributes for that child class. So that's really what they're referring to there. Then they say commonly overridden methods, and then they're just really referring to the str method, which isn't super important. It's more of a visual thing for knowing what certain objects, um, like what attributes belong to certain objects of a class. And then the delete method, which is what it sounds like, it deletes stuff. Um, and then multiple inheritance, like I said, don't worry about multiple inheritance. So, whew, I gotta catch my breath. Okay. I hope this helped at least a little bit. Object-oriented programming might seem complicated, but it's really not. You have a class, you have your init method, which really just, your init method will have characteristics, or what we call them as attributes. These attributes are kind of like, they are, yeah, they are characteristics of whatever the class name is. So if my class name is parrot, my parrot will have a name, will have an age, and both of those are characteristics of the parrot class, of a parrot, but we call them attributes. So you have the class name, your init method, which is always included, a list of different attributes, and then you're going to have more methods. I mean, you don't have to have more methods, but typically you would have other methods aside from just your init method. And these other methods describe actions that your whatever class you created does. So in this case, my parrot would would sing, it would dance. I mean, I don't know if a parrot dances. I've never actually seen a parrot, but maybe it does. I do know parrots sing, so yeah. And then inside of these methods can do certain things. It can return strings. It can also do some calculations. They can do a lot of different stuff. And then that's it for your class, really. It's as simple as that. Now, yes, we just created a class and we gave it attributes and we gave it actionable things that it does, but it's pointless to have a map if we never use the map. It's like going to the gas station back in 2000, buying a map of the map of the United States because you're going on a road trip. What's the point in buying a map and then shoving it into your glove compartment box and then not using it? It's useful to use the map. So in this case, we're using the map, and the way to use a map is to initialize a new object. An object is just like a specific parrot in this case. In this case, their parrot is called Blue, and they're saying when you initialize a new object, it's whatever the object name is for that you want to create, and then you do equals, and then whatever class you want that object to be initialized to. In this case, we want it to be initialized to the parent class, and these these arguments that I'm passing have to match the arguments that exist inside of the init method. But remember, you just ignore the self. Yes, we have to include self when we declare any method inside of our class, in any class you create. But when we're passing arguments, we don't have to worry about self. So I'm just passing two arguments to worry about name and age, and then they get assigned here. That's all that's happening. And then if you want to call specific methods, so if I want to reference these methods inside of my class, you just do the name of your new object, period, the name of the method. So sing or dance, and then pass any arguments that you might need. Like I said, in this case, I need to pass one argument for song, and then for this other method, I don't have to pass anything because there's no actual parameter that requires me to pass an argument. It's as simple as that. At its most basic form, it's as simple as that. And then inheritance, I've gone over it a lot, so I think I explained inheritance well enough. Encapsulation. Encapsulation is kind of just if you don't want a user to change a value of a attribute, so in this case the attribute of max price, you just do a double underscore before the attribute name inside of your class when you're writing your class. And then if the user tries to change it by calling that attribute and assigning a new value to it, it won't stick. They can enter in whatever they want, but Python won't accept that value because Python's going to say, hey, this attribute's protected or private, so I'm not going to allow them to change the value. Now, if it was protected, it would only have one underscore before it, and the user would be able to change the value, but don't worry about protected too much, just worry about private, because private's the actual useful one. Polymorphism we're not doing, and that's really it. So yeah, I did kind of repeat myself quite a bit, but that's just kind of hammer in the point of all of these different subjects. Object-oriented programming is super useful, as you can tell, because we're actually writing code that more closely relates to how things exist in the real world. In the real world, we have the human race, and think of the human race as a class. And we might have different races. We might have different ethnicities, I guess. And those different ethnicities can be they can be child classes. So I could have a child class for people of Hispanic descent, a child class for people of African descent, of Asian descent. So those could all be child classes, but the parent class can be the human race. And then attributes of humans can be like all humans have eyes, ears, mouths, but for all those child classes, it might be like we might have specific attributes like different skin color, different hair color, different eye color, stuff like that. But we're still taking from the parent class of using the super function of carrying over those base attributes of 2 arms, 2 legs, 1 head. All humans have those. So it's important to carry those attributes over to the child classes. So that's why we use a super function. So stuff like that. And so it it's more humanized coding when we're doing object-oriented programming in Python. Obviously, Python is an object-oriented programming language, but when we write code like this, we're really fully taking advantage of the object-orientedness of Python. So once again, I'm done talking. 1 hour and 10 minutes I think is enough. I hope this helped. I really basically just covered chapter 7 in its totality. So week 11 and week 12, this is why I wanted to cover it all in one video, because if I just covered it in half, it would be, I think, a little bit more confusing, because you'd be like, okay, I get up to this point, and then like the next week, like you might forget, so that's why I want to throw it at you all at once. So if you do come back to reference this video, it's all there. So yeah, that's it for week 12. I will be posting the lab activity relatively soon, probably by Sunday you'll see it. And then the PowerPoint as well on Sunday. I just want to get this out first because it's kind of it's important. This is a big topic. It's covering 2 weeks. So you'll definitely see this on the test. Maybe we won't, on the test you won't see all the little aspects of object-oriented programming, but I will probably have some questions on it. So I feel like this video is important to get out as soon as possible. So yeah, I'll see you guys in week 13. Alright. Well, in the lab activity walkthrough this week, and then in week 13. But yeah, I'll see you guys in the next video.